An athlete performs a long jump, leaves the ground at 27 degrees with respect to horizontal angle and lands at 7.8 meters away. What was the takeoff speed? So again, we have here two numbers. We have angle theta with respect to horizontal for the initial velocity v initial and this is x-axis. Angle theta is 27 degrees. And we have distance between initial and final point, delta x equals 7.8 meters. Keep in mind that we know gravity acceleration, which is minus 9.8 meter per second square, because we will always put y-axis upward, x-axis to the right. Now let's draw a picture. We have ground, we have athlete, which moves over the parabola from initial point to the final point. We have v initial, and it's not given to us. We have to find this quantity, but we have angle theta. Now we have to choose the origin, where to put origin of the coordinate system. We have 2 points, initial, final. Either one can be used as origin. I will put origin at initial point. So y-axis will be here, x-axis here, and this is our origin. So what do we know about initial point? Because it's origin, x initial will be 0 and y initial will be 0 as well. Vx initial will be v initial times cosine theta. Vy initial will be v initial times sine theta. That's general formulas, and this is what we know about initial point. What do we know about final point? We'll know that x final is distance from origin, in our case, from initial point, and this is 7.8 meters. This is our distance covered by the athletes during the jump. Y final is 0. Nothing else you know. So now it's time to pick up appropriate equations. Because we have horizontal motion, we always have to use equation for the horizontal motion. X final equal x initial plus Vx initial times delta t. If you plug in here your data, you will have 7.8 meters equal 0 meters plus unknown V initial times cosine 27 degrees times delta t. Unfortunately, this equation has two unknowns, V initial and delta t. So you cannot solve this equation for the V initial without knowing delta t. So we need one extra equation from which we can find delta t. And what equation we have to pick up from the vertical motion? Because we have y final and y initial, we can grab equation which has y final, y initial, vy initial, and delta t. General equation looks like y final equal y initial plus vy initial delta t minus 1/2 g delta t square. If you will plug in here your data, you will have 0 equal 0 plus v initial sine theta delta t minus 1/2 9.8 meter per second square delta t square. How to solve this equation? This is algebra 1. You can factor delta t and you will have 0 equal delta t times v initial sine 27 degrees minus 1/2 9.8 meter per second square times delta t. So we have two solutions. First solution is delta t equal to 0. But this solution corresponds to the initial moment of time whenever athlete is sitting, it's still at the initial point. So it's not our solution. Second, we have to equal our expression into the brackets to 0 and find delta t. So we have v initial sine 27 degrees minus 4.9 meter per second square delta t equal to 0. From here, delta t will be equal to v initial sine 27 degrees divided by 4.9 meter per second square. And we can grab this delta t and plug in equation for the horizontal motion. We will have 7.8 meters equal v initial square cosine 27 degrees times sine 27 degrees divided by 4.9 meter per second square. Solving this equation for the v initial, you will find that v initial in our case will be equal 9.72 meters per second. We solved the whole problem.